If you want to do it the other way, have at it. The next example dealt with a vector problem, and we will have a vector problem on the practice problems. We have two vectors here that are forces acting upon a charge, one electron. And we're asked to find what is the resulting electric field. So we have to find, we got two forces here on our vector diagram here, up and to the right. We're not going to find angle for this, we're just going to find the resulting strength of this thing. So, we're trying to find the resultant force. F sub r I'm using for resultant force. Well, this is just, when you draw your parallelogram, you see that you're going to have a right triangle, so all you need is the Pythagorean theorem. And because they both have the same exponents for their forces, which I have written here as -5, and they're actually -14. Then I'm going to just use the Pythagorean theorem without those, and then, so I'm dropping the times 10 to the -14 momentarily. I do that, I get 4.66. Now I'm going to bring back the 10 to the -14 because it all washes out in this square root. And I get 4.66 times 10 to the -14, and this is a force, so that is newtons. And the equation for finding the electric field is force over charge. Force, which is this, over charge, which is the number of coulombs for one electron, which, like I said, is 1.60 times 10 to the -19 coulombs. And I get 2.91 times 10 to the 5th newtons per coulomb. Okay? The next example deals with drawing electric fields from one charge to another. In this case, they're both negatively charged. Now, your book has a couple of examples of equal charges and what they look like. This is what the attraction. Now, you notice that there's just a ton on the opposite side over here, and that's because when you represent two charges that are attracted to each other, you're going to put more arrows or more lines coming off of the larger quantity than you are the smaller quantity. So we have this and the attraction between them. Now these are actually attracting over here, but they are making these gigantic loops and coming back around, which I wasn't in the mood to write. But and I also want to represent the fact that the number of lines I have over here is approximately triple this. Why? Because the strength of this charge here is 3 times greater than the strength of this charge here. And I have them going from positive to negative, which is one of the stipulations of drawing electric fields. If had this both been positive, they'd be going like this. You know, almost look like a giant insect with a big proboscis right there. But there will be like what we call in calculus, an asymptote between the two areas right there. They never will come close to each other because they are like charges and they will repel. So there's that you have to deal with. So your assignment for this is found at the end of the script. You have 5 problems to do. Have fun.